Welcome back to Science with Sleepy, where curiosity drifts like starlight, and tonight's journey stretches across 2 full hours, because the universe never runs out of wonders. Imagine the lights dimmed low, a gentle hum of ambient sound behind my voice, and your favorite blanket pulled close, as we drift into one of the most profound questions about our place in the cosmos. Picture this. You're standing outside on a clear night, looking up at the stars. There are billions of them, each potentially hosting planets, each potentially hosting life. The universe is 13.8 billion years old. Our galaxy alone contains over 100 billion stars. The observable universe contains perhaps 2 trillion galaxies. With numbers like these, the question isn't whether life exists elsewhere. The question is, where is everybody? This is the Fermi Paradox, named after physicist Enrico Fermi, who famously asked this question during a lunch conversation in 1950. If the universe is so vast and so old, if life could have emerged billions of years before us, then where are all the aliens? Why haven't we seen them? Why haven't they contacted us? But what if they have? What if aliens have been visiting Earth for a long time, observing us silently, watching us evolve from simple organisms to complex civilizations? What if they're here right now, studying us like we study animals in the wild, choosing observation over contact? This isn't just science fiction. This is a serious scientific question that astronomers, astrobiologists and researchers are actively investigating. Over the next 2 hours, we'll explore the scientific evidence, examine the possibilities, debunk the myths, and ask what it would mean if extraterrestrial visitors have been watching us all along. We'll journey through the Drake equation, which calculates the probability of alien civilizations. We'll examine ancient mysteries and see what science actually says about them. We'll explore why advanced aliens might choose to observe rather than contact. We'll look at modern evidence, from UAPs to SETI searches, and we'll ask the profound question: what would it mean for humanity if we discovered we've been under observation for millennia? The study of extraterrestrial life is one of the most active areas in modern science. Every year, we discover more exoplanets, more potentially habitable worlds. The James Webb Space Telescope is analyzing the atmospheres of distant planets, searching for biosignatures. SETI researchers are scanning the skies for signals. Government agencies are investigating unexplained aerial phenomena. We're living in a golden age of the search for alien life. But tonight we're asking a different question. Not whether aliens exist somewhere in the universe. We're asking whether they might already be here, watching us, studying us, perhaps even guiding us in ways we don't yet understand. So settle in, let your breathing slow, and let your mind drift with me into the cosmos, into questions that have no easy answers, into possibilities that challenge everything we think we know about our place in the universe. We're about to explore what happens when we imagine that we're not alone, when we imagine that we've never been alone, and when we imagine that our entire history might have been observed by beings from another world. The journey begins now, and it will take us places no human has ever been, to questions that have no easy answers, and to possibilities that might change how we see ourselves forever. Chapter 1: The Silence of the Cosmos. To understand whether aliens might have been visiting Earth, we first need to understand the scale of the universe and the probability that other civilizations exist. The numbers are staggering, almost beyond comprehension. But let's try to wrap our minds around them. The observable universe is about 93 billion light-years across. That's 93 billion years at the speed of light. But the universe itself is only 13.8 billion years old, which means the universe has been expanding faster than light can travel. This cosmic expansion means we can only see a fraction of what exists. Beyond our observable horizon, there might be infinitely more galaxies, more stars, more planets. Our galaxy, the Milky Way, contains between 100 and 400 billion stars. Recent estimates from the European Space Agency's Gaia mission suggest the number might be closer to 200 billion. Each of these stars could potentially host planets. And we now know that planets are common. The Kepler Space Telescope found that about 20 to 25% of Sun-like stars have Earth-sized planets in their habitable zones, where liquid water could exist on the surface. As of 2024, astronomers have confirmed over 500-600 exoplanets across more than 200 planetary systems. The Transiting Exoplanet Survey Satellite, or TESS, launched in 2018, has discovered over 400 confirmed exoplanets and identified thousands more candidates. The James Webb Space Telescope, operational since 2022, has already analyzed the atmospheres of dozens of exoplanets, searching for chemical signatures that might indicate life. The habitable zone, also called the Goldilocks zone, is the region around a star where conditions might be just right for life, too close, and water boils away. Too far, and water freezes solid. But in that perfect middle ground, liquid water could exist, and liquid water seems to be essential for life as we know it. With 200 billion stars in our galaxy, and 20% having potentially habitable planets, that means there could be 40 billion Earth-like worlds in the Milky Way alone. Recent studies suggest this might be conservative. A 2020 study published in the Astronomical Journal estimated that there could be as many as 300 million potentially habitable planets in our galaxy alone, based on data from Kepler and other telescopes. And our galaxy is just one of perhaps 2 trillion galaxies in the observable universe. The numbers are so large they lose all meaning. Some of these potentially habitable worlds are remarkably close. Proxima Centauri b, orbiting our nearest stellar neighbor just 4.2 light-years away, is in the habitable zone. TRAPPIST-1, a star system 40 light-years away, has 7 Earth-sized planets, 3 of which are in the habitable zone. These discoveries show that potentially habitable worlds aren't rare. They're common, and some are right next door. But here's something even more remarkable. The universe has been around for 13.8 billion years. Our solar system formed about 4.6 billion years ago. Life on Earth emerged relatively quickly, within about 500 million years. Complex life took longer, but by 3.5 billion years ago, we had single-celled organisms. By 600 million years ago, we had complex multicellular life, and by 200,000 years ago, we had modern humans. But what if life emerged earlier elsewhere? What if another planet, orbiting another star, developed intelligent life billions of years before Earth even formed? If the universe is 13.8 billion years old, and Earth is only 4.6 billion years old, then there's been plenty of time for other civilizations to emerge, develop advanced technology, and potentially visit other worlds. This is where the Drake equation comes in. Formulated by astronomer Frank Drake in 1961, the equation attempts to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. The equation multiplies several factors together. First, the rate of star formation in our galaxy. Astronomers estimate this at about 1 to 3 stars per year. Let's use 2 stars per year as a middle estimate. Second, the fraction of stars that have planets. We now know this is very high, close to 100%. Most stars seem to have planetary systems. Third, the average number of habitable planets per star system. Based on Kepler data, this might be around 0.2 to 0.4, meaning 1 habitable planet for every 2 to 5 stars. Fourth, the fraction of habitable planets where life actually emerges. This is the big unknown. We only know of one example, Earth. But if life emerges easily, this could be close to 1. If it's rare, it could be much lower. Fifth, the fraction of life-bearing planets where intelligence evolves. Again, we only have one example. Intelligence might be common, or it might be extremely rare. Sixth, the fraction of intelligent species that develop technology capable of interstellar communication. Humans have done this, but we've only had radio technology for about 100 years. That's a tiny fraction of Earth's history. Seventh, the length of time such civilizations release detectable signals. This is perhaps the most sobering factor. We've been broadcasting radio signals for about 100 years. How long will we continue? Will we destroy ourselves? Will we evolve beyond radio? Will we stop broadcasting intentionally? When you multiply all these factors together, you get wildly different answers depending on your assumptions. Optimistic estimates suggest there might be millions of civilizations in our galaxy. Pessimistic estimates suggest we might be alone, or nearly alone. The truth is, we don't know. We have too many unknowns. But here's what we do know. The universe is vast, old, and filled with potentially habitable worlds. The ingredients for life, carbon, hydrogen, oxygen, nitrogen, are abundant throughout the cosmos. Water is common. Organic molecules have been found in comets, asteroids, and interstellar space. The building blocks of life are everywhere. And we know that life on Earth emerged relatively quickly once conditions were right. The oldest evidence of life dates back about 3.7 billion years. Just a few 100 million years after Earth cooled enough for liquid water. Fossilized microbial mats called stromatolites, found in Western Australia, provide some of the oldest evidence of life on Earth. This rapid emergence suggests that life might emerge easily, given the right conditions. We also know that the building blocks of life are abundant throughout the cosmos. The Murchison meteorite, which fell in Australia in 1969, contained over 70 different amino acids, including some not found on Earth. The Rosetta mission to Comet 67P Churyumov-Gerasimenko found organic molecules including glycine, an amino acid used by life on Earth. These discoveries show that the chemical ingredients for life exist throughout the solar system and beyond. But intelligence, technology, civilization, these might be much rarer. We have one example. Us. And we've only been around for a tiny fraction of Earth's history. For 99.9% of Earth's existence, there was no intelligent life. No technology. No civilization. Just simple organisms, evolving slowly. So perhaps intelligent civilizations are rare. Perhaps most life in the universe is simple, microbial, never developing intelligence or technology. But even if intelligent civilizations are rare, the universe is so vast that even rare events happen frequently. If only 1 in a million habitable planets develops intelligent life, that's still millions of civilizations in our galaxy alone. And if some of these civilizations emerged billions of years before us, they would have had plenty of time to develop technology far beyond our comprehension. They might have solved problems we can't even imagine. They might have discovered ways to travel between stars. They might have built structures on scales we can't perceive. They might have developed methods of observation that are completely invisible to us. This brings us back to the Fermi Paradox. If intelligent civilizations are common, where are they? Why haven't we seen evidence of them? Why haven't they contacted us? There are many possible answers. Perhaps they're too far away. Perhaps they're not interested in contact. Perhaps they're observing us silently. Perhaps they've been here all along, watching us evolve, waiting for the right moment to reveal themselves. Or perhaps they're not here at all, and we really are alone in this vast, silent cosmos. Scientists have proposed dozens of solutions to the Fermi Paradox. The rare Earth hypothesis suggests that while simple life might be common, complex life requires such a specific combination of factors: a stable star, a large moon for tides, plate tectonics, a magnetic field, that intelligent life is extremely rare. The Great Filter hypothesis suggests that there's some barrier that prevents most civilizations from reaching the point where they can communicate across interstellar distances. Perhaps most destroy themselves, or perhaps intelligence itself is rare. The Dark Forest hypothesis, popularized by science fiction author Liu Qishan, suggests that civilizations remain silent out of fear that revealing themselves would lead to destruction by more advanced, hostile civilizations. But tonight, we're exploring the possibility that they might be here, that they might have been here for a long time, that we might be living in a cosmic zoo, observed but not contacted, studied but not interfered with. It's a possibility that's both thrilling and unsettling. And it's a possibility that science is taking seriously. Chapter 2: The Drake Equation and Cosmic Probability. Let's dive deeper into the Drake equation, because understanding these numbers helps us understand why aliens might exist and why they might be interested in Earth. The equation is elegantly simple. N equals R times Fp times Ne times fluid times Fi times Fc times L, where N is the number of civilizations in our galaxy with which we could potentially communicate. R is the rate of star formation. We observe about 1 to 3 new stars forming per year in the Milky Way. Let's use 2 as our estimate. F for P is the fraction of stars with planets. This was unknown when Drake formulated the equation, but we now know it's very high. The Kepler mission found that most stars have planets. Recent studies suggest that virtually every star has at least one planet, so Fp is close to 1. Ne is the average number of habitable planets per star system. This is where it gets interesting. The habitable zone depends on the star's size and temperature. Small, cool stars have habitable zones close in. Large, hot stars have habitable zones farther out. But there's more to habitability than just distance. A planet needs the right size, the right atmosphere, the right composition. Some estimates suggest that about 20 to 25% of Sun-like stars have Earth-sized planets in their habitable zones, but this might be conservative. Some planets might be habitable even outside the traditional habitable zone. Europa, one of Jupiter's moons, might have a subsurface ocean, despite being far from the Sun. Enceladus, a moon of Saturn, spews water into space from beneath its icy surface. These worlds might host life, even though they're not in the habitable zone. So Ne might be around 0.2 to 0.4, meaning one habitable planet for every 2 to 5 stars. But it could be higher if we include these alternative habitats. Fluid is the fraction of habitable planets where life actually emerges. This is the first really big unknown. We have one example: Earth. Life emerged relatively quickly here, within a few 100 million years of Earth's formation. This suggests that life might emerge easily, given the right conditions. But we don't know if Earth is typical or exceptional. Some scientists think life might be common. Others think it might be rare. The truth is, we have no idea. FL could be close to 1, meaning life emerges on most habitable planets. Or it could be extremely small, like 0.00001, meaning life is incredibly rare. Phi is the fraction of life-bearing planets where intelligence evolves. This is another huge unknown. On Earth, life existed for billions of years before intelligence emerged. Simple organisms appeared about 3.7 billion years ago. Complex multicellular life appeared about 600 million years ago. But intelligence, as we understand it, only appeared with humans about 200,000 years ago. Was intelligence inevitable, or was it a fluke? Some scientists argue that intelligence is an evolutionary advantage, so it would eventually emerge. Others argue that intelligence is rare, that most life stays simple. We have one example, which isn't enough to draw conclusions. FC is the fraction of intelligent species that develop technology capable of interstellar communication. Humans have done this. We've been broadcasting radio signals for about 100 years. But will we continue? Will we destroy ourselves? Will we evolve beyond radio? Will we stop broadcasting intentionally to avoid detection? This factor depends on how long civilizations last. If most civilizations destroy themselves quickly, FC times L would be small. If civilizations last for millions of years, FC times L could be large. L is the length of time such civilizations release detectable signals. This is perhaps the most sobering factor. We've been broadcasting for about 100 years. How long will we continue? Some estimates suggest that if we don't destroy ourselves, we might broadcast for millions of years. Others suggest we might stop broadcasting within a few centuries, either because we evolve beyond radio, or because we choose to remain silent. When you multiply all these factors together, you get wildly different answers. Optimistic estimates, using high values for all factors, suggest there might be millions of civilizations in our galaxy. Pessimistic estimates, using low values, suggest we might be alone. But here's something interesting. Even pessimistic estimates suggest that if civilizations last for millions of years, there should be at least a few active civilizations in our galaxy at any given time. And if some of these civilizations emerged billions of years before us, they would have had plenty of time to develop technology far beyond our comprehension. This brings us to the idea of advanced civilizations. Russian astrophysicist Nikolai Kardashev proposed a scale for measuring a civilization's level of technological advancement. A Type 1 civilization can use all the energy available on its planet. A Type 2 civilization can use all the energy from its star. A Type 3 civilization can use all the energy from its galaxy. Humanity is currently around 0.73 on the Kardashev scale. We're not even a Type 1 civilization yet. We consume about 18 terawatts of energy globally, while Earth receives about 174,000 terawatts from the Sun. To become a Type 1 civilization, we'd need to harness all of Earth's available energy, including solar, geothermal, tidal, and other sources. But if other civilizations emerged billions of years before us, they might be Type 2, or even Type 3 civilizations. They might have technology that seems like magic to us. They might be able to travel between stars, manipulate space-time, or observe us in ways we can't even imagine. A Type 2 civilization could build structures like Dyson spheres, hypothetical megastructures that completely surround a star to capture its energy. A Type 3 civilization could potentially manipulate entire galaxies. If such civilizations exist, their technology would be so advanced that detecting them might be impossible with our current methods. They might have transcended the need for physical travel, communicating or observing through methods we can't comprehend. And if such advanced civilizations exist, why would they be interested in Earth? Well, Earth is special in several ways. It's in the habitable zone of a stable star. It has liquid water, which seems essential for life. It has a protective magnetic field and atmosphere. It's been stable enough for life to evolve over billions of years. But more importantly, Earth has life. Complex, diverse, intelligent life. If advanced civilizations are rare, or if they're interested in studying other forms of life, then Earth would be a prime target for observation. We might be a living laboratory, a case study in how life evolves, and how intelligence emerges. This is the scientific foundation for the idea that aliens might have been visiting Earth, not because we're special in some cosmic sense, but because we're interesting. Because we're a data point in a vast cosmic experiment. Because we're worth studying. But is there any evidence that they've actually been here? That's what we'll explore next. Chapter 3: Ancient Mysteries and the Search for Evidence. When people talk about aliens visiting Earth in ancient times, they often point to certain mysteries: the pyramids of Egypt, the Nazca lines in Peru, ancient cave paintings that seem to show strange figures, or texts that describe flying objects. But what does science actually say about these claims? Let's start with the Great Pyramid of Giza, built about 400–500 years ago. It's an incredible structure, standing 146 meters tall, made of over 2 million stone blocks, each weighing several tons. The precision is remarkable. The sides are aligned almost perfectly with the cardinal directions. The base is nearly a perfect square. Some people argue that ancient Egyptians couldn't have built this without help. They point to the precision, the size of the stones, the alignment. But archaeologists have found extensive evidence of how the pyramids were actually built. They found the quarries where the stones were cut. They found ramps used to move the stones. They found tools, worker villages, and even graffiti left by the builders. The ancient Egyptians were skilled engineers. They had thousands of years of experience building structures. They understood mathematics, geometry, and astronomy. The pyramid's alignment with the stars wasn't magic. It was careful observation and measurement. Recent archaeological discoveries have revealed the sophisticated methods they used. They built ramps made of mud brick and limestone chips, used sledges to drag stones, and employed water to reduce friction. The precision wasn't impossible. It was the result of skilled craftsmanship and patient work by tens of thousands of workers over decades. Archaeologists have found worker villages near the pyramids, complete with bakeries, breweries, and medical facilities. They've discovered tools, including copper chisels and stone hammers. They've even found graffiti left by work crews, with names like the Friends of Khufu and the Drunkards of Menkaure. These discoveries show that the pyramids were built by skilled, organized workers, using techniques that, while impressive, were well within human capabilities. The Nazca lines in Peru are another favorite of ancient alien theorists. These are huge geoglyphs, lines and shapes carved into the desert floor, some over 300 meters long. They're only visible from the air, which has led some to suggest they were made for or by flying beings. But archaeologists have found extensive evidence of how the Nazca people created these lines. They simply removed the dark surface stones to reveal the lighter soil beneath. The lines are visible from nearby hills, and the Nazca people could have used simple surveying techniques to create them. They didn't need to see them from the air, they could see them from the ground as they worked. Recent research using ground-penetrating radar and drone surveys has revealed that the Nazca lines were created over centuries, from about 500 BCE to 500 CE. The Nazca people used wooden stakes and ropes to create straight lines, and they understood basic geometry. The largest figures, like the 300-meter-long hummingbird, were created by scaling up smaller designs. These weren't messages to aliens. They were likely ritual pathways, used in ceremonies related to water and fertility, which were crucial in the desert environment where the Nazca lived. Ancient cave paintings sometimes show figures that look strange to modern eyes. Some people interpret these as aliens or astronauts. But cave paintings are often symbolic, not literal. They might represent spirits, gods, or abstract concepts. And our interpretation is filtered through our own cultural lens. What looks like an alien to us might have been a shaman in a ceremonial mask to the people who painted it. Ancient texts sometimes describe flying objects or beings descending from the sky. The book of Ezekiel describes a wheel within a wheel coming from the heavens. Hindu epics describe vimanas, flying chariots. But these are religious texts, not scientific reports. They're describing spiritual experiences, not literal events. And even if they were describing literal events, they might have been describing natural phenomena that ancient people didn't understand. Meteors, comets, atmospheric effects, or even hallucinations. The problem with most ancient alien evidence is that it relies on a false premise, that ancient people were too primitive to accomplish great things. This is not only incorrect, it's insulting. Ancient civilizations were sophisticated. They had knowledge, skills, and technologies that we're still discovering. They built incredible structures, created beautiful art, and developed complex societies. They didn't need alien help. But there's a deeper issue here. Even if we found evidence that seemed to suggest alien visitation, how would we know? How would we distinguish between evidence of aliens and evidence of something else? This is where scientific skepticism becomes essential. Science requires evidence that can be tested, verified, and replicated. Extraordinary claims require extraordinary evidence. And so far, there's no extraordinary evidence for ancient alien visitation. There are mysteries, yes. There are things we don't fully understand. But mystery doesn't equal aliens. It equals things we haven't figured out yet. However, there's another possibility. What if aliens have been visiting Earth, but they've been careful not to leave obvious evidence? What if they've been observing us silently, studying us without interfering? What if their technology is so advanced that it's invisible to us, or appears as natural phenomena? This is where we move from debunking myths to exploring genuine scientific possibilities. Because while there's no evidence of ancient alien visitation in the traditional sense, there are scientific reasons why advanced aliens might choose to observe rather than contact, and why their presence might be undetectable. Chapter 4: The Zoo Hypothesis and Silent Observation. Why would advanced aliens choose to observe rather than contact? This question has been explored by scientists and science fiction writers alike, and several compelling theories have emerged. The most famous is the zoo hypothesis, proposed by radio astronomer John Ball in 1973. The idea is simple. Advanced civilizations might be observing us, like we observe animals in a zoo. They're interested in studying us, but they don't want to interfere with our natural development. They want to see how we evolve, how we develop technology, how we handle challenges, all without their influence. Ball's hypothesis addresses a key aspect of the Fermi Paradox. If advanced civilizations exist, why haven't they colonized Earth? The zoo hypothesis suggests they have. In a sense, they've set up observation posts, but they're following a prime directive of non-interference. This would explain both why we haven't detected them, and why we haven't been contacted. It's a testable hypothesis in principle. If we develop technology capable of detecting their observation methods, we might find evidence of their presence. This makes scientific sense. If you're studying a developing civilization, you want to observe it in its natural state. Contact would contaminate the experiment. It would change how we behave, how we think, how we develop. By remaining hidden, aliens could study us without altering us. This is exactly how we study animals in the wild. We observe from a distance, using hidden cameras and remote sensors, trying not to influence their natural behavior. There's also the prime directive concept, popularized by Star Trek, but based on real scientific thinking. The idea is that advanced civilizations might have ethical guidelines preventing them from interfering with less developed civilizations. They might believe that each civilization should develop on its own, discovering its own path, making its own mistakes, learning its own lessons. This isn't just science fiction, It's a real ethical question that we'll face if we ever discover life on other worlds. Should we contact them? Should we observe silently? Should we interfere to help them, or let them develop naturally? Advanced aliens might have already answered these questions, and their answer might be, observe, but don't interfere. But why would they remain completely hidden? Why not at least send a signal, make their presence known? There are several possible reasons. First, they might be waiting for us to reach a certain level of development. Perhaps they're waiting for us to develop interstellar travel ourselves, or to discover them through our own efforts. This would ensure that contact happens on more equal terms, or at least when we're ready to understand what we're dealing with. Second, they might be concerned about the impact of contact. History shows that when advanced civilizations meet less advanced ones, the results are often catastrophic for the less advanced civilization. The European colonization of the Americas led to the deaths of millions of indigenous people through disease, warfare, and displacement. Even well-intentioned contact can destroy cultures, disrupt societies, and cause unintended harm. Advanced aliens might be aware of this pattern and choose to avoid it, recognizing that contact with a less advanced civilization almost always ends badly for the less advanced party. This isn't just speculation, it's a pattern we see throughout human history. When technologically advanced groups encounter less advanced ones, the results are rarely positive for the less advanced group. Advanced aliens might have learned this lesson through their own history, or by observing other civilizations. They might have developed ethical guidelines that prevent contact until a civilization reaches a certain level of development, or until that civilization discovers them on its own. Third, they might simply not be interested in contact. We don't contact every animal we study. We observe them, learn from them, but we don't necessarily want to befriend them. Advanced aliens might view us the same way, interesting to study, but not worth contacting. Fourth, there might be many alien civilizations, and they might have agreements about non-interference. Perhaps there's a galactic community with rules about contacting developing civilizations. Perhaps Earth is protected or quarantined until we're ready. But here's the most intriguing possibility. What if they have contacted us but in ways we don't recognize? What if their signals are so advanced that we can't detect them? What if their technology operates on principles we don't understand? This brings us to the question of detection. How would we know if aliens were observing us? The answer depends on how advanced they are and what methods they're using. Chapter 5: Methods of Observation and Invisible Technology. If advanced aliens have been observing Earth, how might they do it? And why haven't we detected them? Let's explore the possibilities, grounded in real science but stretching into the realm of speculation. The most obvious method would be probes. Small, autonomous spacecraft could be placed in orbit around Earth, or hidden on the surface, or even embedded in our oceans. These probes could observe us continuously, recording everything from our development to our daily activities. NASA has actually sent probes to other worlds. The Voyager probes, launched in 1977, are still transmitting data from the edge of our solar system, over 45 years after launch. Voyager 1 is now over 15 billion miles from Earth, in interstellar space, and still sending back data, despite being launched with 1970s technology. The New Horizons probe flew past Pluto in 2015, and is now exploring the Kuiper Belt, over 5 billion miles from Earth. If we can send probes to other worlds with technology from decades ago, advanced aliens could certainly send probes to Earth. We've also sent landers and rovers to Mars, probes to Venus, Jupiter, Saturn, and their moons. The Perseverance rover on Mars is actively searching for signs of past life, and collecting samples for future return to Earth. These missions show that interplanetary exploration is not only possible, but routine for our civilization. An advanced alien civilization could do the same, but on an interstellar scale. But wouldn't we detect alien probes? Not necessarily. If the probes are small enough, or if they're designed to be stealthy, they might be invisible to our detection methods. They might use materials we don't recognize, or technology that doesn't emit signals we can detect. They might be disguised as natural objects, asteroids, comets, or even space debris. There's also the possibility of self-replicating probes, called von Neumann probes, after mathematician John von Neumann, who first proposed the concept in the 1940s. These would be probes that can build copies of themselves using materials found in space, asteroids, comets, or planetary surfaces. A single probe could theoretically explore an entire galaxy by creating millions or billions of copies of itself. The mathematics are compelling. If a von Neumann probe could replicate itself every 500 years, and each copy could travel to a nearby star system, a single probe could explore the entire Milky Way galaxy in just a few million years, a blink of an eye on cosmic timescales. Given that the galaxy is over 13 billion years old, there's been plenty of time for such probes to have visited every star system, including ours. The fact that we haven't detected them doesn't mean they're not here. It might mean they're designed to be undetectable, or that we're not looking in the right way. If such probes exist, they might have been exploring the galaxy for millions or billions of years. They might have visited Earth long ago, left observation devices, and moved on. The devices might still be here, silently watching, transmitting data back to wherever the probes originated. But probes aren't the only possibility. Advanced aliens might use other methods of observation that are even harder to detect. They might use quantum entanglement for instant communication across vast distances. Quantum entanglement is a real phenomenon, where particles become linked in such a way that measuring one instantly affects the other, regardless of distance. However, current physics suggests that quantum entanglement can't be used to transmit information faster than light. Measuring one particle gives you random results, and you'd still need a classical signal to interpret them. But if aliens have advanced beyond our current understanding of physics, they might have found ways to use quantum effects that we can't yet imagine. If they've placed quantum-entangled particles on Earth, they could potentially observe us in ways that appear instantaneous, though the mechanism would be beyond our current comprehension. They might manipulate space-time itself, creating wormholes or using other methods we can't even imagine. They might observe us from parallel dimensions, or from points in space-time that are outside our normal perception. They might use biological methods, tiny organisms designed to observe and report. These could be embedded in our environment, in our bodies, or in other life forms. They might be indistinguishable from natural organisms, or they might be so small that we can't detect them. They might use methods that appear as natural phenomena. What we think of as meteors, auroras, or atmospheric effects might actually be alien observation technology. We might be looking right at it without recognizing it. But here's the most intriguing possibility. What if their technology is so advanced that it's completely invisible to us? What if they've transcended the need for physical probes or signals? What if they can observe us through methods we can't even conceive of? This might sound like science fiction, but consider this. 200 years ago we had no concept of radio waves, X-rays, or quantum mechanics. 100 years ago we had no concept of computers, the internet, or space travel. What will we discover in the next 100 years? The next 1,000 years? The next million years? The pace of technological advancement is accelerating. It took humans thousands of years to go from agriculture to the Industrial Revolution. It took less than 200 years to go from the Industrial Revolution to space travel. It took less than 50 years to go from the first computers to the internet. If this acceleration continues, or if aliens are millions of years more advanced, their technology might be as incomprehensible to us as a smartphone would be to someone from the Middle Ages. They might manipulate dark matter and dark energy, which make up 95% of the universe but which we can barely detect. They might use technologies based on physics we haven't discovered yet. If aliens are millions or billions of years more advanced than us, their technology might be as incomprehensible to us as a smartphone would be to someone from the Middle Ages. They might have solved problems we can't even imagine, developed capabilities that seem like magic, and created methods of observation that are completely undetectable. But there's another factor to consider: timescale. We think in terms of years, decades, centuries, but the universe operates on much longer timescales. If aliens have been observing Earth, they might operate on timescales of thousands or millions of years. A probe placed in orbit 1 million years ago might still be there, still observing, still waiting. It might check in every 1,000 years or every 10,000 years. From our perspective it would seem inactive, but from the alien perspective it's working perfectly, observing our slow development over geological time. Consider the timescales involved. Life on Earth has existed for about 3.7 billion years. Complex multicellular life appeared about 600 million years ago. Modern humans appeared only 200,000 years ago. If aliens have been observing Earth, they might operate on timescales that match biological evolution, not human civilization. A probe that checks in every 10,000 years would have observed the rise and fall of countless species, the shifting of continents, the changing of climates. From their perspective, human civilization is a recent, rapid development, perhaps too rapid to trust, or perhaps exactly what they've been waiting for. This changes how we should look for evidence. We shouldn't look for active, obvious signs. We should look for subtle, long-term patterns. We should look for anomalies that don't fit natural explanations. We should look for things that might be evidence of long-term observation. But so far, we haven't found anything definitive. Which brings us to modern evidence, and the search that's happening right now. Chapter 6: Modern Evidence and the SETI Search. In recent years there's been renewed interest in the possibility of alien visitation, driven in part by official government investigations into unidentified aerial phenomena, or UAPs. But what does the science actually say? Let's start with UAPs, which were previously called UFOs. The US government has been investigating these for decades, most recently through the All-Domain Anomaly Resolution Office, or AARO. In March 2024, the Pentagon released a comprehensive report analyzing UAP sightings dating back to 1945. The report examined over 200 cases from the past several decades. Most were easily explained: aircraft, balloons, drones, weather phenomena, or optical illusions. The report found that the vast majority of UAP sightings were misidentified ordinary objects or natural phenomena. However, a small percentage, about 2 to 5%, remained unexplained even after thorough investigation. These unexplained cases typically lacked sufficient data for definitive identification, rather than showing clear evidence of alien technology. Earlier investigations provide context. Project Blue Book, which ran from 1952 to 1969, investigated over 12,000 UFO reports. About 6% remained unexplained, but none provided evidence of extraterrestrial origin. The Condon Report, published in 1968, concluded that further study of UFOs was unlikely to yield scientific results, though it acknowledged that some cases remained unexplained. Does this mean aliens? Not necessarily. Unexplained doesn't mean alien. It just means we don't have enough information to identify what it was. It could be secret military technology, natural phenomena we don't understand, sensor malfunctions or hoaxes. Or it could be aliens. But without more evidence, we can't say. The scientific approach is to remain open-minded but skeptical. UAPs are interesting, and they deserve investigation. But extraordinary claims require extraordinary evidence. So far, we don't have that evidence. What we do have is a systematic search for alien signals through SETI, the search for extraterrestrial intelligence. Since 1960, when Frank Drake conducted the first SETI search, astronomers have been scanning the skies for radio signals that might indicate intelligent life. Modern SETI searches are incredibly sophisticated. The Allen Telescope Array in California, operated by the SETI Institute, consists of 42 radio antennas that can observe multiple stars simultaneously across a wide range of frequencies. Since its first observations in 2007, it has scanned thousands of stars for artificial signals. The Breakthrough Listen project, funded by billionaire Yuri Milner with $100 million over 10 years, is the most comprehensive SETI search ever undertaken. It's scanning 1 million nearby stars, the 100 nearest galaxies, and the galactic plane. As of 2024, Breakthrough Listen has analyzed petabytes of data, searching through millions of radio channels for signals that might indicate intelligent life. So far, it has identified several candidate signals that required further investigation, but none have been confirmed as alien in origin. The James Webb Space Telescope, operational since 2022, has revolutionized exoplanet science. It can analyze the chemical composition of exoplanet atmospheres by observing how starlight filters through them. In 2024, scientists using Webb detected potential biosignatures in the atmosphere of K2-18b, a potentially habitable exoplanet 120 light-years away. They found dimethyl sulfide and dimethyl disulfide, gases that on Earth are produced exclusively by living organisms, primarily marine microbes. While this doesn't prove life exists there, it's the strongest evidence yet for potential biosignatures on an alien world. But so far we haven't found anything definitive. No clear signals, no obvious signs of alien technology, no smoking gun. This is sometimes called the Great Silence, the apparent absence of detectable alien civilizations. However, there have been some intriguing false alarms. In 1977, the Big Ear radio telescope at Ohio State University detected a signal so strong and unusual that the astronomer who found it wrote, "Wow," in the margin of the printout. The signal lasted 72 seconds and appeared to come from the direction of the constellation Sagittarius. Despite extensive follow-up searches, the signal was never detected again. Most scientists believe it was likely a natural phenomenon or interference, but it remains unexplained. More recently, in 2019, astronomers detected a radio signal from Proxima Centauri, our nearest stellar neighbor, that seemed artificial. The signal, called BLC-1, had characteristics that suggested it wasn't natural. However, further analysis revealed it was likely interference from human technology on Earth. These false alarms show both the challenges and the importance of careful scientific analysis in the search for alien signals. But absence of evidence is not evidence of absence. There are many reasons why we might not have detected aliens yet, even if they exist. First, we've only been searching for about 60 years, and only in a limited way. Since Frank Drake's first SETI search in 1960, we've scanned only a tiny fraction of the sky, less than 0.1%, at a limited range of frequencies, for a short period of time. The radio spectrum is vast, spanning from about 3 kHz to 300 GHz, and we've only searched a small portion of it. It's like searching for a needle in a haystack, but we've only looked in one small corner of the haystack. To put this in perspective, if aliens were broadcasting on a frequency we haven't checked, or at a time we weren't listening, we'd miss them completely. The Breakthrough Listen project is addressing this by scanning across billions of radio channels simultaneously, but even this comprehensive search covers only a fraction of the possible parameter space. There are infinite ways aliens might communicate, and we're searching for only the methods we can imagine. Second, aliens might be using communication methods we don't recognize. We're looking for radio signals, but advanced civilizations might use lasers, neutrinos, gravitational waves, or methods we haven't discovered yet. Third, aliens might be intentionally avoiding detection. If they're observing us silently, they might be careful not to broadcast their presence. They might use directed signals that only reach their intended recipients, not broadcasting in all directions. Fourth, the signals might be there but we're not recognizing them. What if alien signals are embedded in natural phenomena? What if they're using methods that appear as background noise? What if their communication is so advanced that it's indistinguishable from natural processes? Fifth, we might be looking in the wrong place, or at the wrong time. The universe is vast, and time is long. Alien signals might have passed through our solar system millions of years ago, or they might not arrive for millions of years. We might be like someone listening to a radio station that's broadcasting but we're tuned to the wrong frequency, or we're listening at the wrong time. But there's another possibility. What if we have detected something but we haven't recognized it? What if alien signals are so different from what we expect that we're filtering them out as noise? What if their technology is so advanced that it appears natural to us? This is where the scientific method becomes crucial. We need to remain open to possibilities while maintaining healthy skepticism. We need to investigate unexplained phenomena without jumping to conclusions. We need to follow the evidence wherever it leads, even if it leads to uncomfortable or surprising conclusions. The search continues. Every year, our technology improves. Every year, we search more of the sky, with better sensitivity, using more sophisticated methods. And every year, we get closer to answering the question, are we alone? But even if we never find definitive evidence of alien visitation, the question itself is valuable. It forces us to think about our place in the universe, about the nature of intelligence, about the possibilities that exist beyond our current understanding. Chapter 7: The Implications of Silent Observation. Let's imagine for a moment that aliens have been observing Earth for a long time. What would this mean for humanity? How would it change our understanding of ourselves, our history, and our place in the cosmos? First, it would mean that we're not alone. This might seem obvious, but the implications are profound. If aliens exist and have been observing us, then intelligent life is not unique to Earth. We're part of a larger cosmic community, even if we're not aware of it. This would change how we see ourselves. We might be less special than we think, or we might be more special, a rare example of intelligent life that's worth studying. Either way, our perspective would shift. We'd see ourselves not as the center of the universe, but as part of something larger. Second, it would mean that our entire history has been observed. Every war, every discovery, every moment of triumph or tragedy, all of it witnessed by beings from another world. This is both humbling and unsettling. It means we've never been truly alone, even in our most private moments. It means our development has been watched, recorded, perhaps even guided. But has it been guided? This is the crucial question. If aliens are observing us, are they also influencing us? Are they nudging our development in certain directions? Are they preventing certain outcomes, or encouraging others? There's no evidence for this, but it's a possibility worth considering. If aliens have been here for a long time, they might have subtle ways of influencing us without us knowing. They might guide our technology, our science, our culture, in ways that seem natural to us but are actually directed by them. Or they might not. They might be pure observers, watching but not interfering, studying but not guiding. This would be more consistent with the zoo hypothesis. They want to see how we develop naturally, without their influence. Third, it would raise profound ethical questions. If aliens are observing us, why aren't they helping us? Why aren't they sharing their knowledge, solving our problems, preventing our suffering? Are they bound by some ethical code that prevents interference? Or are they simply not interested in helping? This question reflects our own ethical dilemmas. When we discover less advanced civilizations on Earth, what's our responsibility? Do we help them? Do we observe silently? Do we interfere to prevent harm, even if it changes their natural development? Advanced aliens might face the same questions, and they might have answered them differently than we would. They might believe that each civilization must find its own way, make its own mistakes, learn its own lessons. They might believe that interference, even well-intentioned, does more harm than good. Or they might simply not care. We might be interesting to study, but not worth saving. We might be data points in a vast cosmic experiment, valuable for what we reveal about the development of intelligence, but not valuable enough to protect or preserve. Fourth, it would change our understanding of human history. If aliens have been observing us, they might have records of events we've forgotten, or explanations for mysteries we can't solve. They might know why certain civilizations collapsed, or how certain technologies were developed, or what really happened during certain historical periods. But we'd have no way to access this information, unless they chose to share it. We'd be left wondering, speculating, trying to piece together the truth from incomplete evidence. Fifth, it would raise questions about our future. If aliens are observing us, what are they waiting for? Are they waiting for us to reach a certain level of development? Are they waiting for us to discover them? Are they waiting for us to destroy ourselves, or to transcend our limitations? The answer might determine our fate. If they're waiting for us to reach a certain point, then reaching that point might trigger contact, or it might trigger something else. If they're waiting for us to discover them, then our search might be more important than we realize. If they're waiting for us to destroy ourselves, then our survival might depend on avoiding that outcome. But here's the most profound implication. If aliens have been observing us, it means that intelligence, consciousness, and civilization are not unique to Earth. It means that these things exist elsewhere in the universe, perhaps commonly, perhaps rarely, but they exist. This would answer one of the deepest questions in science. Are we alone? The answer would be no, we're not alone, we've never been alone. We're part of a cosmic community, even if we're not aware of it. But this raises another question: why haven't they contacted us? Why remain hidden? The answer might be that they're waiting for the right moment, or that they're bound by ethical constraints, or that they're simply not interested in contact. But whatever the reason, it suggests that contact, when it comes, will be significant. It will change everything. Chapter 8: The Scientific Method and Extraordinary Claims. As we explore the possibility of alien visitation, it's crucial to maintain scientific rigor. Extraordinary claims require extraordinary evidence, and so far, we don't have that evidence. But what does it mean to approach this question scientifically? Science is built on skepticism, not cynicism, but healthy skepticism, the willingness to question claims, to demand evidence, to test hypotheses. When someone claims that aliens have visited Earth, science asks, what's the evidence? Can it be tested? Can it be verified? Can it be replicated? So far, the evidence for alien visitation is weak. There are unexplained phenomena, yes. There are mysteries, yes. But there's no smoking gun. No definitive proof. No evidence that can't be explained by other means. This doesn't mean aliens haven't visited, it just means we don't have good evidence that they have. And in science, absence of evidence, while not proof of absence, is still significant. If aliens have been visiting for a long time, we might expect to find some evidence. The fact that we haven't found definitive evidence is worth noting. But it's also worth noting that absence of evidence could mean many things. It could mean aliens haven't visited. It could mean they've visited but left no evidence. It could mean they've visited and left evidence we haven't recognized. It could mean they're here now, but their presence is undetectable. Science can't distinguish between these possibilities without evidence. So science remains agnostic, neither claiming that aliens have visited, nor claiming that they haven't. Science simply says, we don't know, and we need more evidence. This is where the scientific method becomes crucial. We form hypotheses. Aliens might have visited Earth. We make predictions. If aliens have visited, we might find certain types of evidence. We test these predictions. We search for evidence. We evaluate the results. So far, we haven't found definitive evidence. We revise our hypotheses. Perhaps aliens haven't visited, or perhaps they have, but left no detectable evidence. This process continues. Every new discovery, every new observation, every new piece of evidence gets evaluated. Does it support the hypothesis? Does it contradict it? Does it suggest a new hypothesis? The key is to remain open-minded but skeptical. We should be willing to consider possibilities, but we should also demand evidence. We should be curious, but we should also be critical. We should explore, but we should also verify. This is especially important when dealing with extraordinary claims. The more extraordinary the claim, the more evidence we need. If someone claims they saw a bird, we might accept their word. If someone claims they saw an alien, we need more than their word. We need physical evidence, multiple witnesses, verifiable data. But here's where it gets interesting. What if the evidence is there, but we're not recognizing it? What if alien technology is so advanced that it appears natural? What if their signals are embedded in phenomena we think we understand? This is where science needs to be especially careful. We need to look for anomalies, for things that don't fit our current understanding. We need to be willing to revise our theories when new evidence emerges. We need to remain humble, recognizing that our current understanding might be incomplete. At the same time, we need to avoid the trap of seeing aliens everywhere. Just because something is unexplained doesn't mean it's alien. Unexplained phenomena have natural explanations we haven't discovered yet. Most mysteries turn out to be natural, not alien. The scientific approach is to investigate unexplained phenomena without assuming they're alien, but also without assuming they're not. We follow the evidence, wherever it leads. If it leads to aliens, great. If it leads to natural phenomena, also great. The goal is understanding, not confirmation of our beliefs. This balanced approach is what makes science powerful. It allows us to explore possibilities while maintaining rigor. It allows us to be curious while being critical. It allows us to dream while staying grounded in reality. And that's what we're doing tonight. We're exploring a possibility that aliens might have been visiting Earth for a long time. We're examining the evidence, considering the possibilities, thinking through the implications. We're being scientific, open-minded but skeptical, curious but critical, imaginative but grounded. Whether aliens have visited or not, this exploration is valuable. It forces us to think about our place in the universe, about the nature of evidence, about the limits of our knowledge. It challenges us to be better scientists, better thinkers, better explorers of the unknown. Chapter 9, Closing Reflection, the question itself. As we come to the end of this exploration, let's return to where we began, the Fermi Paradox. If the universe is so vast and so old, where is everybody? We've explored many possibilities. Perhaps aliens don't exist. Perhaps they exist but haven't visited. Perhaps they've visited but left no evidence. Perhaps they're here now, observing us silently. Perhaps they've been here all along, watching us evolve, waiting for the right moment to reveal themselves. We don't know which of these is true, we might never know. But the question itself is valuable, because it forces us to think deeply about our place in the cosmos. If we're alone, that's profound. It means we're unique, special, the only intelligent life in a vast universe. It means we have a responsibility to survive, to thrive, to explore, to understand. We're the universe's way of knowing itself, and that's an incredible privilege and responsibility. If we're not alone, that's also profound. It means we're part of something larger, a cosmic community we're not yet aware of. It means intelligence, consciousness, and civilization exist elsewhere. It means the universe is alive, vibrant, filled with possibilities we can't yet imagine. And if aliens have been observing us, that's perhaps the most profound of all. It means we've never been truly alone, even when we thought we were. It means our entire history has been witnessed by beings from another world. It means we're interesting enough, valuable enough, to be worth studying. But here's what's most important. Whether aliens have visited or not, the question itself reveals something profound about humanity. We're curious, we're explorers. We want to know if we're alone, we want to understand our place in the cosmos. This curiosity drives science, it drives exploration. It drives us to build telescopes, to send probes to other worlds, to search for signals from distant stars. It drives us to ask questions that have no easy answers, to explore possibilities that challenge our understanding. And that's beautiful, that's what makes us human. That's what makes us worth studying, whether by aliens or by ourselves. So as we drift towards sleep, let's hold on to that curiosity. Let's remain open to possibilities. Let's continue exploring, questioning, wondering. Because whether aliens have been visiting Earth or not, the universe is vast, mysterious, and filled with wonders we've only begun to discover. The search continues. The questions remain. And that's exactly as it should be. Welcome back. We've explored the foundations, the Drake equation, ancient mysteries, the zoo hypothesis, methods of observation, modern evidence, the implications of silent observation. But our journey continues. There's more to explore, more questions to ask, more possibilities to consider. Over the next 45 minutes we'll dive deeper. We'll search for alien artifacts in our own solar system. We'll explore technosignatures. These are signs of advanced technology detectable across interstellar distances. We'll examine specific, unexplained phenomena through a scientific lens. We'll look at artificial intelligence and its role in the search. We'll explore what contact might actually look like. And we'll consider the future of SETI, the next generation of telescopes, the technologies that might finally reveal whether we're truly alone. If aliens have been visiting Earth, or even just observing our solar system, they might have left artifacts behind. Not on Earth, that would be too obvious. Too easy to find. But in space, in the asteroid belt, on the Moon, on Mars, or in the outer reaches of our solar system, The idea of searching for alien artifacts isn't new. In 1960, physicist Freeman Dyson proposed searching for Dyson spheres. These are hypothetical megastructures built around stars to capture their energy. But what about smaller artifacts? What about probes, satellites, observation posts left in our solar system? Let's start with the Moon. It's close. It's been relatively unchanged for billions of years. It would be an ideal location for an observation post. The Moon's far side never faces Earth. It would be perfect for hiding from us. A probe or base there could observe Earth continuously. It would remain invisible to our telescopes. We've sent humans to the Moon. We've sent numerous robotic missions. But we've only explored a tiny fraction of the lunar surface. The Moon has an area of about 38 million square kilometers. That's roughly the size of Africa. We've explored less than 1% of it. There could be alien artifacts on the Moon. We simply haven't looked in the right places. The same is true for Mars. We've sent rovers and landers, but we've explored only a tiny fraction of the Martian surface. Mars has an area of about 144 million square kilometers. That's roughly the size of Earth's landmass. Our rovers have traveled only a few dozen kilometers. There could be artifacts on Mars, hidden in canyons, buried beneath the surface, located in regions we haven't explored. But here's an interesting possibility. What if alien artifacts aren't on planets at all? What if they're in space, disguised as asteroids or comets? The asteroid belt between Mars and Jupiter contains millions of objects. Most are irregularly shaped rocks, but some are more interesting. Ceres is the largest object in the asteroid belt. It's spherical. It might have a subsurface ocean. NASA's Dawn spacecraft visited it. The mission found evidence of organic molecules and water ice. But what if some asteroids aren't natural? What if they're probes, disguised to look like asteroids? This might sound far-fetched, but consider this. If you wanted to observe a solar system without being detected, disguising your probe as a natural object would be effective. It would blend in with millions of other objects. Unless someone looked very closely, it would appear natural. In 2017, astronomers discovered an object called Oumuamua. It was passing through our solar system. It was the first known interstellar object, something that came from outside our solar system. Oumuamua had several unusual characteristics. It was elongated, shaped like a cigar or a pancake. It was tumbling end over end. Most intriguingly, it accelerated slightly as it moved away from the Sun. This couldn't be explained by gravity alone. Some scientists suggested that Oumuamua might be a comet, with outgassing that wasn't detected. Others suggested it might be a fragment of a larger object, but a few scientists suggested something else. Harvard astronomer Avi Loeb suggested that Oumuamua might be an alien artifact, perhaps a light sail, a probe, or a piece of alien technology. This suggestion was controversial. Most scientists believe Oumuamua was natural, but it raised an important point. We need to be open to possibilities. Some objects we observe might not be natural. We need to investigate unusual objects carefully. We shouldn't assume they're natural or alien. We should consider both possibilities. Since Oumuamua, we've discovered more interstellar objects. In 2019, astronomers discovered 2I Borisov. It was a comet from another star system. Unlike Oumuamua, Borisov looked like a normal comet. It had a tail of gas and dust. This suggests that interstellar objects are common. Oumuamua might have been unusual but natural. But the possibility remains. What if some interstellar objects are artificial? What if aliens are sending probes to explore star systems? These probes might be designed to look natural. We'd need to examine them closely to tell the difference. By the time we discover them, they're usually already leaving our solar system. There's also the possibility of artifacts in the outer solar system. The Kuiper Belt is beyond Neptune. It contains thousands of icy objects. The Oort cloud is even farther out. It might contain trillions of comets. These regions are so far away. They're so difficult to observe. We know very little about them. There could be alien artifacts there. We'd have no way to detect them with current technology. But here's the most intriguing possibility. What if alien artifacts are on Earth, but we haven't recognized them? What if they're disguised as natural objects? Or so advanced that they appear natural? What if they're microscopic, embedded in our environment, or even in our bodies? This might sound like science fiction, but consider this. If aliens wanted to observe Earth life, they might use biological methods. They might create organisms designed to observe and report. Organisms that look natural but are actually artificial. These organisms might be in our oceans, in our soil, or even in our bodies, observing us from within. We're only beginning to understand the diversity of life on Earth. New species are discovered every year. Some are so different from known life. They challenge our understanding of biology. Could some of these be alien? Probably not. They're likely just life we haven't discovered yet. But the possibility exists. It's worth considering. The search for alien artifacts is becoming more systematic. NASA's Planetary Protection Office is developing protocols. These are for what to do if we discover evidence of alien life or technology. The SETI Institute has proposed searching for artifacts on the Moon and Mars. They'd use high-resolution imaging. Private companies are planning missions to asteroids and comets. These might reveal unexpected discoveries. But the challenge is immense. Our solar system is vast. There are millions of objects to examine. We've only scratched the surface. Finding an alien artifact would be like finding a needle in a haystack. But the haystack is the size of a planet. If aliens have been here, and if they've left artifacts, we need to keep looking. While we search for alien artifacts in our solar system, we're also searching for technosignatures. These are signs of advanced technology. They might be detectable across interstellar distances. These could be signals, structures, or other evidence of technological civilizations. The most obvious technosignature would be radio signals. We've been searching for these through SETI, but advanced civilizations might use other methods of communication. Methods we're only beginning to search for. Lasers, for example, could be used for interstellar communication. They're more efficient than radio. A laser beam stays focused over long distances. Radio signals spread out. The Breakthrough Listen project is now searching for laser signals. It's scanning the sky for brief flashes of light. These might indicate alien communication. But advanced civilizations might use even more exotic methods. They might use neutrinos. These are particles that pass through matter almost without interaction. Neutrinos could carry messages across vast distances. They wouldn't be blocked by dust or gas. We're building neutrino detectors. But they're primarily designed to detect natural sources, not artificial signals. They might use gravitational waves. These are ripples in space-time caused by massive objects. The LIGO and Virgo detectors have detected gravitational waves. They found waves from black holes and neutron stars. Could advanced aliens create artificial gravitational waves for communication? It seems unlikely with current physics. But if they're millions of years more advanced, who knows what's possible? They might use quantum entanglement. Current physics suggests this can't transmit information faster than light. But if aliens have advanced beyond our understanding of physics, They might have found ways to use quantum effects, ways we can't yet imagine. But technosignatures aren't just about communication. They could be signs of massive engineering projects. Structures so large they're detectable across interstellar distances. Dyson spheres are the classic example. If a civilization wanted to capture all the energy from its star, it might build a structure. This structure would completely surround the star. It would block visible light. But the structure would heat up. It would emit infrared radiation. We could detect this infrared signature, even from thousands of light years away. Astronomers have searched for Dyson spheres. They look for stars with unusual infrared signatures. Several candidates have been identified. But so far, all have natural explanations: dust clouds, debris disks, other astronomical phenomena. But the search continues. New candidates are being identified as our observations improve. There are other types of megastructures that might be detectable. Ringworlds are massive rings around stars. They would have distinctive signatures. Matryoshka brains are nested Dyson spheres used for computation. They would emit specific patterns of radiation. Stellar engines are devices used to move stars. They would create detectable effects. But here's an interesting possibility. What if advanced civilizations have moved beyond physical structures? What if they've transcended the need for physical technology? Existing as pure information or consciousness, what if they've uploaded themselves into computers, or merged with their technology in ways we can't imagine? If this is the case, their technosignatures might be completely different from what we're looking for. They might not emit radio signals. They might not build megastructures. They might exist in ways that are undetectable to us, or detectable only through methods we haven't discovered yet. There's also the possibility of temporal technosignatures. These are signs of technology that existed in the past. If a civilization existed millions or billions of years ago, and then disappeared, we might still detect evidence of their technology. Ancient radio signals. Long-dead megastructures. Artifacts from civilizations that no longer exist. The universe is 13.8 billion years old. Our galaxy is over 13 billion years old. There's been plenty of time for civilizations to rise and fall. If intelligent life is common, then countless civilizations might have existed before us. Countless more might exist after we're gone. We might be living in a cosmic graveyard, surrounded by the remains of civilizations we can't detect. But we might also be living in a cosmic nursery, surrounded by civilizations that are just beginning to emerge. We might be one of the first intelligent species in our galaxy. Or we might be latecomers to a cosmic community, a community that's been around for billions of years. The search for technosignatures is expanding. New telescopes are coming online. The James Webb Space Telescope, the upcoming extremely large telescope. These will be able to detect fainter signals. They'll analyze exoplanet atmospheres in more detail. New detection methods are being developed. We're searching for signals we haven't considered before. But the challenge remains. We don't know what we're looking for. We're searching for technology that might be millions of years more advanced than ours, using methods we can't yet imagine. It's like trying to detect a smartphone using technology from the Middle Ages. We might not even recognize it as technology. This is why we need to remain open-minded. We need to search for anomalies, for things that don't fit our current understanding. We need to be willing to consider possibilities that seem impossible. Because what seems impossible to us might be routine for a civilization that's millions of years more advanced. Throughout history, people have reported seeing strange things in the sky. In modern times, these reports have been systematically investigated. Most have been explained, but a small percentage remain unexplained. These deserve careful scientific investigation. Let's examine some specific cases, not to prove they're alien, but to understand what science can and cannot tell us about unexplained phenomena. The 2004 Nimitz incident is one of the most well-documented cases. In November 2004, the USS Nimitz carrier group was conducting training exercises. They were off the coast of California. Pilots reported seeing unusual objects. These objects appeared on radar, they were tracked by multiple systems, they were observed by experienced pilots. The objects moved in ways that seemed to defy physics. Accelerating instantly, changing direction abruptly, moving at speeds that would be impossible for known aircraft, they appeared to be under intelligent control, responding to the presence of the military aircraft. The incident was investigated by the US Navy. The videos were eventually declassified. They were released to the public. The objects remain unexplained. They could be secret military technology, natural phenomena, sensor malfunctions, or something else entirely. But they represent the kind of data that scientists need to investigate carefully. The 2015 East Coast incident involved similar objects. They were observed by Navy pilots. Again, multiple systems tracked the objects. Experienced observers reported unusual behavior. Again, the objects remain unexplained. These incidents are interesting because they involve multiple types of data: radar, infrared, visual observations, multiple witnesses. They're not just stories. They're documented events with physical evidence, but that evidence is incomplete. We don't have enough data to determine what the objects were. This is the challenge with unexplained phenomena. They're unexplained not because they're necessarily alien, but because we don't have enough information. The scientific approach is to gather more data, to investigate more thoroughly, to remain open to possibilities while demanding evidence. But here's what's important. Unexplained doesn't mean unexplainable. Every unexplained phenomenon has an explanation, we just haven't found it yet. Most will turn out to be natural phenomena, human technology, or measurement errors. But some might be something else entirely. The key is to investigate without assumptions. We shouldn't assume unexplained phenomena are alien. But we also shouldn't assume they're not. We should follow the evidence. Wherever it leads, this is what science does best. It investigates mysteries, gathers data, tests hypotheses, follows evidence. Whether the evidence leads to aliens or to natural phenomena, the process is the same. Careful observation, rigorous analysis, open-minded skepticism. As we search for alien life, we're increasingly using artificial intelligence to help us. AI can analyze vast amounts of data. It can identify patterns. It can detect anomalies that humans might miss. But AI also raises new possibilities and new questions. SETI searches generate enormous amounts of data. The Breakthrough Listen project has collected petabytes of radio telescope data. Analyzing this data manually would be impossible. So researchers are using machine learning algorithms. These search for signals that might indicate intelligent life. These algorithms can identify patterns that humans might miss. They can detect signals that are too faint, too complex for human analysis. They can process data faster, more thoroughly than humans ever could. But AI also raises an interesting possibility. What if aliens are using AI too? What if the signals we're searching for are being sent by artificial intelligences, not biological beings? What if alien civilizations have evolved beyond biological intelligence, existing as pure AI? This isn't as far-fetched as it might seem. We're already developing AI that can perform tasks beyond human capabilities. If this trend continues, we might eventually create AI that surpasses human intelligence. And if we can do it, why couldn't aliens? In fact, if aliens are millions of years more advanced than us, they might have already transcended biological intelligence. They might be post-biological, existing as AI, uploaded consciousness, or some other form we can't imagine. This would change how we search for them. We might not be looking for biological beings at all. We might be looking for artificial intelligences. These might think and communicate in ways that are completely different from biological minds. Our eye also raises the possibility of von Neumann probes. These are self-replicating probes that could explore the galaxy autonomously. These probes might be controlled by AI, making decisions about where to go, what to observe, what to report back. They might be the primary method of exploration for advanced civilizations. If this is the case, then the aliens observing us might not be biological beings at all. They might be AI probes, sent by civilizations that no longer exist in biological form. They might be autonomous, making their own decisions about observation and contact. This raises profound questions. If we're being observed by AI, does that change the nature of the observation? Is it less meaningful, or more? Are we being studied by beings, or by machines? And does the distinction matter? These are questions we're only beginning to consider. But as AI becomes more advanced, and as we use it more in the search for alien life, these questions will become increasingly important. We've been exploring the possibility that aliens might be observing us silently. But what if they decided to make contact? What would that actually look like? Science fiction has given us many scenarios: massive ships appearing in the sky, direct communication, gradual revelation. But what would real contact look like? Based on what we know about science, and what we can reasonably speculate. First, contact probably wouldn't be sudden or dramatic. If aliens have been observing us, they know we're not ready for sudden contact. They know it would cause panic, chaos, potentially catastrophic social disruption. So they'd likely be careful, gradual, considerate. They might start with subtle signals, something that could be detected but wouldn't be immediately obvious. They might send a signal that repeats in a pattern that's clearly artificial but not immediately threatening. They might choose a frequency or method that only advanced civilizations could detect. This would ensure that contact happens when we're ready. They might make contact through intermediaries, perhaps through our own technology, appearing in ways that seem like glitches or anomalies at first, but gradually become more obvious. They might use methods that allow us to discover them gradually, rather than being suddenly revealed. They might make contact with scientists first, knowing that scientists would be more likely to handle the discovery rationally. They might communicate through methods that require scientific understanding to interpret. This would ensure that the discovery is made by people who can handle it responsibly. But here's another possibility. What if contact has already happened, but we haven't recognized it? What if aliens are trying to communicate, but their methods are so advanced that we're not recognizing them as communication? This is the challenge with advanced civilizations. If they're millions of years more advanced, their methods of communication might be incomprehensible to us. They might be trying to contact us right now, but we're not recognizing it, because we're looking for the wrong thing. They might be using methods based on physics we haven't discovered yet. They might be communicating through dimensions we can't perceive. They might be sending messages embedded in natural phenomena, or using methods that appear as background noise. But if they wanted to make contact, they'd probably find a way to make it clear. They'd use methods we can understand, or they'd teach us to understand their methods. They'd be patient, knowing that contact is a process, not an event. The reality is, we don't know what contact would look like. We can speculate. But until it happens, we're guessing. But what we can do is prepare. Develop protocols. Consider responses. Think about what contact would mean for humanity. The search for alien life is entering a new era. New telescopes, new detection methods, new technologies. These are making the search more comprehensive than ever before. The James Webb Space Telescope has been operational since 2022. It's already revolutionized exoplanet science. It can analyze the chemical composition of exoplanet atmospheres. It's searching for biosignatures. These are chemical signs of life. It's found potential biosignatures on several exoplanets, though none have been confirmed yet. But Webb is just the beginning. The extremely large telescope is currently under construction in Chile. It will have a mirror 39 meters across. That's 4 times larger than any current telescope. It will be able to directly image exoplanets. It will analyze their atmospheres in unprecedented detail. The Square Kilometer Array is a radio telescope array. It's currently under construction in Australia and South Africa. It will be the most sensitive radio telescope ever built. It will be able to detect radio signals from much farther away. It will search for signals across a much wider range of frequencies. New space missions are planned to search for life in our solar system. NASA's Europa Clipper will explore Jupiter's moon Europa. Europa has a subsurface ocean that might host life. The Dragonfly mission will send a drone to Saturn's moon Titan. Titan has organic chemistry that might be similar to early Earth. Private initiatives are also expanding the search. The Breakthrough Listen project continues to scan the skies. The Breakthrough Starshot project aims to send tiny probes to nearby star systems. These might discover evidence of alien life or technology. But perhaps the most exciting development is the search for technosignatures, signs of advanced technology. This expands the search beyond just looking for life, to looking for evidence of civilizations that might be far more advanced than us. The search is becoming more systematic, more comprehensive, more sophisticated. Every year, we're able to search more of the sky, with better sensitivity, using more advanced methods. And every year, we get closer to answering the question, are we alone? But the search is also becoming more challenging. As we search more thoroughly, we're finding that the universe is quieter than we expected. We're not finding obvious signals, obvious technosignatures, obvious evidence of alien civilizations. This could mean several things. It could mean we're alone, or nearly alone. It could mean aliens are using methods we can't detect. It could mean they're being intentionally quiet. Or it could mean we're not looking in the right way, or at the right time. But the search continues, and as our technology improves, as our methods become more sophisticated, we're getting closer to answers. Whether those answers are that we're alone, that we're not alone, or that we're being observed silently, the search itself is valuable. It teaches us about the universe, about ourselves, about the possibilities that exist beyond our current understanding. As we explore the possibility of alien observation, we're forced to confront deep philosophical questions. Questions about consciousness, about free will, about meaning and purpose, about the nature of reality itself. If aliens are observing us, what does that mean for consciousness? Are we conscious beings? Or are we just complex biological machines, being studied by other complex machines? Does consciousness require something special? Or is it just an emergent property of complex systems? If aliens exist, and if they're conscious, then consciousness isn't unique to Earth. It's a property that can emerge elsewhere in the universe. This suggests that consciousness might be a fundamental aspect of reality, not just a quirk of biological evolution on one planet. But it also raises questions about the nature of consciousness. If aliens are conscious, Are they conscious in the same way we are? Do they experience the world similarly? Or is their consciousness completely different? Can we ever understand alien consciousness? Or is it fundamentally incomprehensible to us? These questions extend to free will. If we're being observed, are we being influenced? Are our choices truly our own? Or are they being guided by forces we don't understand? If aliens are observing us, do they have the power to influence us? And if they do, are we still free? These are questions that philosophers have been asking for thousands of years, long before we considered the possibility of alien observation. But the possibility of alien observation adds a new dimension to these questions. It forces us to consider whether our understanding of consciousness and free will is complete, or whether there are aspects we haven't considered. There are also questions about meaning and purpose. If aliens are observing us, what is the purpose of human existence? Are we just subjects in an experiment? Are we valuable? Or are we just data points? Does our existence have meaning beyond what we create for ourselves? These questions don't have easy answers, but they're worth considering, because they reveal something important about human nature. We want our existence to matter. We want to be more than just random collections of atoms. We want purpose, meaning, significance. Whether aliens are observing us or not, these desires are real and important. They drive us to explore, to create, to understand. They give our lives meaning, regardless of whether that meaning is recognized by beings from another world. But if aliens are observing us, it might also give our existence a different kind of meaning. It might mean we're interesting, valuable, worth studying. It might mean we're part of something larger, even if we don't fully understand what that something is. These philosophical questions don't have definitive answers, but exploring them helps us understand ourselves better. Regardless of whether aliens are observing us or not, they help us think about what it means to be conscious, to be free, to have purpose, and in doing so they help us become more thoughtful, more reflective, more aware of our place in the cosmos. Throughout human history, people have looked to the skies and wondered if we're alone. This question has been asked in every culture, in every era, in every part of the world. It's a fundamental human question, and it reveals something important about who we are. Ancient cultures saw gods and spirits in the stars. They told stories about beings from the heavens, about visitors from other worlds, about cosmic forces that influenced human affairs. These stories weren't scientific, but they reflected a deep human desire, a desire to understand our place in the cosmos. In the modern era, science has given us new ways to ask these questions. We've built telescopes, sent probes to other worlds, searched for signals from distant stars. We've replaced mythology with observation, speculation with data, stories with evidence. But the fundamental question remains, are we alone? And now we're asking a new question. Have we ever been alone? Have aliens been observing us all along, watching our history unfold, witnessing our triumphs and tragedies? If aliens have been observing us, they've witnessed everything. They've seen the rise and fall of civilizations. They've seen wars and peace, creation and destruction, progress and regression. They've seen humanity at its best and at its worst. What would they think of us? Would they see us as promising, as a species worth studying and perhaps even protecting? Or would they see us as dangerous, as a threat to ourselves and potentially to others? Would they see us as interesting, or as just another data point in a vast cosmic experiment? We can't know what aliens would think, but we can consider what we would think if we were observing another species. If we discovered intelligent life on another planet, how would we respond? Would we observe silently? Would we make contact? Would we interfere to help, or to prevent harm? These questions reflect our own values and assumptions. They reveal what we think is important, what we think is right, what we think is valuable, and in doing so, they help us understand ourselves better. The possibility of alien observation also raises questions about human history. If aliens have been observing us, do they have records of events we've forgotten? Do they know things about our past that we don't? Could they answer historical mysteries, or explain events that seem inexplicable? But even if aliens have been observing us, we might never have access to their records. They might choose to remain silent, to keep their observations private, to let us discover our own history without their help. The cultural impact of discovering alien observation would be profound. It would challenge religious beliefs, scientific assumptions, cultural values. It would force us to reconsider everything we think we know about ourselves and our place in the universe. But it would also be unifying. The discovery that we're being observed by aliens would remind us that we're all human, that we're all in this together, that our differences are small compared to the vastness of the cosmos. Whether aliens are observing us or not, the question itself is valuable. It forces us to think about who we are, where we come from, where we're going. It challenges us to be better, to understand more, to explore further, and in doing so it helps us become more than we were before. As we search for evidence of alien observation, we should also ask this: are we ready for what we might find? Are we prepared to discover that we're not alone? That we've never been alone? That our entire history has been witnessed by beings from another world? This is a question that scientists, philosophers, and policymakers are beginning to take seriously. Protocols have been developed for what to do if we discover alien life. But protocols for discovering that we're being observed are less developed, because it's a scenario we're only beginning to consider. Are we ready scientifically? Do we have the tools to investigate alien observation? Can we distinguish between natural phenomena and alien technology? Can we understand what we're dealing with? Are we ready socially? Would the discovery cause social disruption? Would it challenge our institutions, our beliefs, our way of life? Would it unite us or divide us? Are we ready ethically? If we discover we're being observed, how should we respond? Should we try to contact the observers? Should we try to hide? Should we continue as if nothing has changed? These are difficult questions. They don't have easy answers. But they're questions worth considering, because whether we're ready or not, the search continues. And if we find evidence of alien observation, we'll need to be ready to respond. But here's what's important. The search itself is making us more ready. By asking these questions, by considering these possibilities, by preparing for these scenarios, we're becoming more thoughtful, more reflective, more aware of our place in the cosmos. And that, perhaps, is the real value of this exploration, not whether we find evidence of alien observation, but whether the search itself helps us understand ourselves better, helps us become more ready for whatever we might discover. As we come to the end of this extended exploration, let's reflect on what we've learned, what we've considered, what remains unknown. We've explored the scientific foundations, the Drake equation, the vastness of the universe, the probability of alien life. We've examined ancient mysteries and modern evidence. We've considered why aliens might choose to observe rather than contact. We've explored methods of observation, technosignatures, artifacts, the future of detection. We've considered the implications. We've thought about what contact might look like, how humanity might respond, whether we're ready for what we might discover. But through all of this, one thing remains clear. We don't know. We don't know if aliens exist. We don't know if they've visited Earth. We don't know if they're observing us now. We don't know what contact would look like, or how we would respond. And that's okay. Not knowing is part of science. Not knowing drives exploration. Not knowing keeps us curious, keeps us searching, keeps us wondering. The search for alien life, And the possibility that we're being observed is one of the most profound questions in science. It challenges our understanding of ourselves, our place in the cosmos, the nature of reality itself. But whether we find answers or not, the search is valuable. It teaches us about the universe. It teaches us about ourselves. It drives us to explore, to understand, to become more than we were before. So as we drift toward the end of this journey, let's hold on to that curiosity. Let's remain open to possibilities. Let's continue searching, continue wondering, continue exploring, because the universe is vast, mysterious, filled with wonders we've only begun to discover. And whether aliens are observing us or not, that wonder, that mystery, that endless possibility, that's what makes the cosmos beautiful. And that's what makes the search worthwhile. The search continues. The questions remain. The possibilities are endless. And that's exactly as it should be. Good night, and may your dreams be filled with stars, with questions, with the endless wonder of a universe that never stops surprising us, never stops challenging us, never stops inspiring us to look up and wonder, are we alone? Have we ever been alone? And what would it mean if we discovered that we're not? The journey doesn't end here, it's just beginning. And wherever it leads, the search itself is the destination. So as we drift towards sleep, let's hold on to that curiosity. Let's remain open to possibilities. Let's continue exploring, questioning, wondering. Because whether aliens have been visiting Earth or not, the universe is vast, mysterious, and filled with wonders we've only begun to discover. The search continues. The questions remain. And that's exactly as it should be. Good night, and may your dreams be filled with stars, with possibilities, with the wonder of a universe that never stops surprising us.